Welcome to qnawire.
Hi, so over here what we know is that the heat that was lost from the hot water needs to equal to the heat that was gained by the cold water. So over here what we're going to find is that the mass of cold water is going to be equal to 100 grams with an initial temperature of 20 degrees Celsius. We know that the final temperature is going to be equal to 32 degrees Celsius. On the other hand, we know that for the hot water, the initial temperature is equal to 70 degrees Celsius, and we don't know what is going to be the mass. Other relevant information is that the heat capacity is equal to 4.586 joules per gram degrees Celsius. So what we're going to get here is that minus the heat of the hot water, which corresponds to mass of hot water times heat capacity times delta T for hot water. This is going to be equal to the mass of cold water times heat capacity times delta T for cold water. We're going to calculate both quantities. Delta T for cold water is going to be equal to 32 degrees Celsius minus 20 degrees Celsius equal to 12 degrees Celsius. Delta T for hot water is going to be equal to final temperature, that is 32 degrees Celsius minus 70 degrees Celsius, which is equal to minus 38 degrees Celsius. So what we get on this case is going to be minus mass of hot water is going to be equal to mass cold water times heat capacity times delta T of cold water divided by heat capacity times delta T for the hot water. The heat capacities are going to cancel out, and we get that the mass of hot water will be equal to minus mass cold water delta T for cold water divided by delta T of hot water. Replacing the values that we got, this is minus 100 grams times delta T for cold water, which is 12 degrees Celsius, divided by delta T for hot water, that is minus 38 degrees Celsius. Minus and minus cancel out, and we get a mass of hot water equal to 31.579 grams of hot water, which is approximately 31.6 grams or 31.58 grams, depending on how many significant figures you're asked in your course.